fenestrated are pretty close, yeah. So here's my weak attempt at a pseudo three-dimensional drawing of a fenestrated capillary. So this, for example, is an endothelial cell. Here's where it joins with the next endothelial cell. And in fenestrated capillaries, these junctions are leaky. But in addition to the leaky junctions, fenestrated capillaries have other holes in the endothelial cells. The cells form open areas that go through the cell, called pores. So the leaky junctions are just a few nanometers across. Too small for anything but very small molecules and atoms to get through. The pores are generally about 60 to 80 nanometers across. If you're not extremely familiar with the metric prefixes for this, put it on the same scale as that. This would be 0.06 to 0.08 microns. So if a red blood cell is 6 to 8 microns across, these are about 100th the size of a red blood cell. So tiny, way too small for any cell. But big enough for pretty much any organic molecule except a protein to get through. So things like glucose, amino acids, individual nucleotides, organic waste molecules, things like that, can pass through these pores quite easily. But not proteins. So, organic molecules can pass freely in and out of fenestrated capillaries. Where would you want to be able to move things like glucose, amino acids, and other organic molecules into and out of the blood very easily?
Kidneys.
Where? In the kidneys, we want to get those. A lot of our wastes are organic molecules. We want to be able to get those out easily. So in certain areas in the kidneys, we have fenestrated capillaries. Where else?
The digestive system.
The liver's a little different. We're going to get to that. Has the third type, but the digestive system is where you want to get nutrients into the blood very quickly. So these are mostly kidneys and digestive. Anywhere where you want to get the molecules of that sort quickly into and out of the blood.
What about the bones? Dr. Rad?
Yes.
What about like your bones?
That's going to be the third type. The third type is called sinusoid. The right number here. The sinusoids are quite a bit bigger than regular capillaries. If a continuous capillary is, say, this, sinusoids are more like this. And they have big gaps in their walls. The endothelial cells don't just have leaky junctions, they have huge holes. So it's almost more like the endothelial cells form a sort of a net where there should be a wall. These have openings in their walls on the scale of 30 to 40 microns across. For reference, how big is a red blood cell? Yeah, So these have holes in their wall big enough for several red blood cells to pass through side by side. What is the point of having a blood vessel that doesn't hold in any part of the blood? Sorry?
To actually let the blood out.
Okay, where would you want to do that?
Like in the organs and stuff.
Which organs do you want to let blood out of the circulatory system?
The liver.
The liver's the main one. In the liver, really, if you've ever dissected a liver, you know it's almost sort of a sponge. It's probably easier to say blood goes into the liver and then just kind of permeates it because the sinusoids really don't keep it in. The sinusoids provide vague suggestions as to where the blood should go and then gather it up on the other side. So the liver cells have direct access to everything that's in the blood, which is why when they have lots of enzymes, they can alter the blood contents. It's also possible for them to add proteins, since the sinusoidal walls have these gigantic cavernous openings. Liver cells can add protein directly to the blood. The liver definitely has these. Where else would that be important?
In the bone where you're making red blood cells.
In the bone marrow. You've got to be able to get red blood cells into the blood somewhere. And on a related notion, the spleen, where we have to get the red blood cells out, and sometimes add them. Those are the three main areas where you find sinusoids. Okay. Other questions about these? Yes?
Do you have more of one than the other as far as those two are concerned? Like,
Fenestrated versus sinusoids?
yeah. Does it matter? Maybe it
It doesn't really matter. I guess maybe more fenestrated, but mostly because you've got a lot of digestive tract.
right?
I don't know. You've certainly got more continuous than anything. Okay, take 5.
Maureen's gonna have.
No, I already did.